Good morning to everybody. Good morning, my dear spicy boys and spongy girls. And so far in system of particles and rotatory motion. So we have studied the complicated motion. So the rigid bodies which are having combination of translator and rotatory motion by using the concept of centroforce. So we are trying to study the motion of those bodies. Now, again, we are going to study the pure rotational motion. Here some examples are given. You know very well. Here you take the fan, how the fan is rotating, ceiling fan. Here the fan is rotating in a circular path. So if you want to rotate a fan in a circular path, there must be one axis. So without using this axis, so we cannot move any body in circular path. For the rotation of these blades, here the axis is perpendicular. The motion of the blades of a fan. You take the motion of the wheel and gears, motors, in different part of the engine is also rotating in circular path. And here, while pushing or pulling a door, or when you are closing or opening a door, it is also belongs to pure rotatory motion. And the spinning up top. So like this, you take so many examples in our day-to-day life. If you take a giant wheel in circus, it is a pure rotatory motion. So in pure rotatory motion, the bodies are moving in a circular path about an axis. So that axis is called axis of rotation. Here the plane of rotation of the body is exactly perpendicular to the axis of rotation. So the motion in which a rigid body rotates about a fixed axis. So every particle of the body moves in a circle which lies in a plane perpendicular to the axis and has its center on the axis. So like this. Here the body is moving in a circular path. This is called horizontal circular path. So this is axis of rotation. For the plane of rotation, here the axis of rotation is perpendicular. For example, if the body is moving in a vertical circular path like this, here the axis of rotation horizontal circular path, vertical circular path. So when a rigid body is moving in a circular path about an axis, each and every particle of the rigid body is also moving in the same circle path. So these all particles form parallel circles. Now, before going to studying pure rotatory motion, so we are going to encounter some parameters. Why? Because we have already studied the translatory motion in previous chapters. So we people studied some literature words about motion of the bodies. So now we are going comparing the parameters which we are going to study in rotatory motion, which those all parameters are comparing with translatory motion. So whereas in linear motion, we have studied distance or displacement, which is shown by S. But the same displacement in rotatory motion, we said it to be called angular displacement, which is shown by theta. Here displacement distance measured in meter centimeter, whereas angular displacement in radians. So you people studied velocity, linear velocity, velocity in linear motion. So various types of velocity you people study. Average velocity, relative velocity, uniform velocity, non-uniform velocity, velocity gradient in linear motion. So whereas we are using this equation in linear motion, dx by dt, the same velocity in rotated motion we studied to be called angular velocity. This is another parameter in rotated motion we are going to be studying. This is called angular velocity. The same velocity in translated motion, linear velocity. Again, acceleration. Now it is called linear. The acceleration of the linear motion, linear acceleration, the rate of change of velocity. But the same acceleration in rotated motion is called angular acceleration. This is the formula. But here rotating body says both acceleration, linear and angular acceleration, linear and angular velocities, and linear displacement, angular displacement. In rotating motion, the bodies which are moving in circular path, so those bodies are having so both displacement, both velocities, and both acceleration. We are also going to study the relation between linear velocity and angular velocity also. But here mass, what role the mass plays in translated motion? The same role played by moment of inertia in rotatory motion. Very, very most important physical quantity, moment of inertia. Then I have some more quantities. You take linear momentum, mv, in linear velocity, in linear motion. The same momentum in rotated motion is called angular momentum. So rotating bodies are having both momentum, linear momentum and angular momentum. Whereas in here force F is equal to ma. The same force in rotated motion we call torque. So in Newton's second law of motion, you people studied how can we measure force. The force is measured in terms of change in momentum, the rate of change of momentum in translatory motion, which is equal to the force acting on the body. But here also, torque is equal to the rate of change of angular momentum. Half mv square, here half I omega square. W work done, Fs. Work done, torque into theta. So what is work done? Work is an agent to transfer energy between two bodies which are at the same temperature. If you want to transfer energy between any two bodies which are at the same temperature, but how? Work is done. Or when work is done, what will happen? Energy is transferred from one body to another body. But here, power is the same power here in rotated motion is equal torque into omega. So these are the comparison of parameters in rotated motion with the linear velocity. Now, these all parameters in rotated motion, now we are going to study in detail. So now I would like to bring an axis of rotation. Here I am showing some pictures. You see here axis of rotation. So this is the axis of rotation. This is the bicycle wheel. The axis of rotation plays very, very most important role in rotatory motion. Why? Because this axis of the position of axis of rotation is most important. And angular displacement, angular velocity, angular momentum, The law of conservation of angular momentum. And here the body is moving. Let us consider a rigid body of mass m. A rigid body of mass m, which is moving on the circumference of this circle. This is the center of this circle. Go is the center of this circle. So the initial position of the body on the circumference is A. The final position is B. So in a short time interval, in dt seconds, the body is moving on the circumference of this circle from A to B in how much time? In dt seconds. Here what happened? Along with the vector OA is also makes some angle at the center of this circle. And on the circumference, the body makes some displacement. The displacement of the body on the circumference, this is linear displacement. This is angular displacement. So this is axis of rotation. So when the body is moving along the circumference of this circle, about an axis, the body may have two displacement. The displacement of the body on the circumference is linear displacement. At the same time, the body makes an angle at the center. So this angle is called angular displacement. This is called linear displacement. So to make this displacement, the body makes some time. If we take s by dt, it gives linear velocity. If theta by dt, angular velocity. So the rotating body has two types of velocities, two types of displacement. This linear displacement is measured in meter, centimeter, whereas this angular displacement is measured in radians. To take theta, d theta by theta, omega. Omega is equal to d theta by dt. So the motion in which now you see that the revolution, when the body is moving in a circular form, at the center what happened? It will make some angle. The motion in which the particle move parallel to one another in various circles about a given axis. The change in angular position of the particle in a given interval of time with a fixed axis is defined as angular displacement. So this is angular displacement. So in this type of motion, angular displacement of all the particles are seen. The angular displacement of all particles of the rigid body is seen. But the linear displacement is not seen. Now once again, angular velocity. When a mass m rotates in the circle from A to B, and you please observe here the body is moving. Here the body is moving from A to B like this. So this is M. Then what happened? The body sweeps some angle. Here in the green color, it is shown in the green color. The angle made by the body at the center of the circle. Now the angle is from here to here 90 degrees. Now 90 degrees. From here to here 180 degrees. $180. From here to here 270, 360 degrees. So the angle made at the center, angular displacement, which is shown by theta, which is measured in radius. The displacement on the circumference, linear displacement. So angular velocity is defined as like this. The rate of change of angular displacement is called angular velocity. Its units are radian per second. So angular velocity very, very most important. If the body is moving one point to another point on the circumference, we take d theta by dt. Suppose if the body makes one complete rotation, you take dt become t, time period. For one complete rotation, how much angle the body will make at the center? 360 degrees, 2 pi radians. So 2 pi by t, angular velocity for one complete rotation in rotatory motion. If the body makes number of rotations, now you take 2 pi n radian per second. Now here's some important facts regarding, you see. No. For anti-clockwise rotation, the direction of angular velocity along the axis of rotation and directed upwards. So angular velocity is a vector quantity. If the body is moving in anti-clockwise direction, the direction of angular velocity is up. So anti-clockwise means like this. So this is anti-clockwise. We may also call counterclockwise. So this is clockwise. So this is clockwise. If the body is moving in clockwise like this. Now this is the axis of rotation. Now clockwise means like this. This is clockwise rotation. So this is anti-clockwise rotation. This is a counterclockwise or anti-clockwise. So in anti-clockwise, the direction of angular velocity along the axis of directed upwards. Here in this case, the direction of angular velocity is in this direction. This is the direction of angular velocity when the body is moving in anti-clockwise direction. This is the direction. Angular velocity. Angular velocity direction. When the body is moving in anti-clockwise along the axis of rotation, vertically up. If the body is moving in clockwise direction, the direction of angular velocity is in the downward direction. Downward. So this is the direction, downward. So what do you understand? The direction of angular velocity is always vertically up, perpendicular to the plane of rotation of the rotating body. If the body completes one revolution, 2 pi by t. The body completes one revolution, 2 pi by t. If the body makes number of rotations, 2 pi n, angular velocity. Now, angular acceleration. The rate of change of angular velocity is called angular acceleration. Alpha is equal to d omega by dt. Alpha is also, we can write A by R. The relation between angular acceleration and linear acceleration. A is equal to R alpha. So your angular acceleration is produced in your body. Angular acceleration is produced in your body when work is done by a torque applied on it. So what is that shall be discussed in further classes. So your angular acceleration is a vector quantity. Its unit is radian per second square. Now, shall we discuss the relation between linear velocity and angular velocity in further class? Okay. Now, angular velocity relation with the linear velocity. So, thank you.